Welcome to another explainer. I am absolutely thrilled to have you here today because we are looking at something that's practically rewiring the future of technology as we speak. We're talking about AI agents, specifically the underlying mechanics that give them the ability to not just talk to us, but actually get things done. Okay, let's dive into this. I want you to think about this for a quick second. Have you ever noticed that a standard AI chatbot can write you a beautifully crafted, award-winning sonnet in like 3 seconds flat? But if you ask it to do something practical, like securely booking a flight or finding a specific file on your computer and emailing it, it just completely falls apart. It is wildly frustrating. And the reason for this blind spot comes down to exactly how standard AI processes complex multi-step tasks. And this brilliantly illustrates what's going wrong. Think about your standard one-shot AI. When you ask it a complex question, it sits entirely in a vacuum. It relies completely on the data it was trained on months or even years ago. So if it doesn't know the answer, it just guesses. Or worse, it confidently hallucinates a totally fake answer. But then, look at what's known as a ReAct agent. Instead of guessing in a vacuum, this agent researches, it takes action, and it actually verifies its information in real time before ever giving you an answer. Section 1. The ReAct Agent Solution. So how exactly did developers solve this huge blind spot? Well, they realized that AI models needed way more than just a massive vocabulary. They needed a structured framework to ground their logic in the real world. Enter ReAct. ReAct stands for Reasoning Plus Acting. Introduced by researchers from Princeton and Google, at its core, it's a prompting pattern. It marries two incredibly powerful concepts: chain of thought reasoning, where the AI thinks out loud step by step, with actual executable tool use. So instead of just generating text, the AI is literally forced to validate its internal logic against real-world outputs. Section 2. Packing for a chirp. To really grasp how groundbreaking this is, we don't even need to dive into complex computer science. We just need to look at how you and I handle everyday problems. Let's use a highly relatable analogy: packing for a trip. When we pack, we don't just blindly throw things into a suitcase and hope for the best, right? We reason and act. Step 1, we ask ourselves what the weather's going to be. So we take an action and check the forecast. Step 2, we realize it's going to be cold. So we look in our closet for a heavy coat. But wait, what if the heavy coat is in storage? We observe that obstacle, adjust our plan, and move to step 3. We decide to pack multiple sweaters to layer up instead. We adapt based on the info we gather. Let's move to and see how this builds. If you map that human packing process directly onto an AI, you get the ReAct loop: thought, action, and observation. This is essentially the holy grail of agentic AI. It's a continuous, repeating cycle that mimics human problem solving. Section 3. Thought, action, observation. Okay, we are going to look a little closer at the mechanics of this loop right now, because understanding these 3 steps is absolutely crucial to understanding how modern AI agents operate. The cycle always begins with a thought. The agent evaluates the context of what you asked it to do. Actually, scratch that. It literally thinks out loud to figure out what information is missing. For example, the thought might be, to pack for this trip, I need to know the weather. I should check the forecast. By generating this text internally, the AI decomposes the larger goal into an immediate, bite-sized subtask. Immediately following that thought comes the action. Because the AI realized it needed the weather, it selects a specific external command or tool to get that data. This isn't just text generation anymore. It is execution. The agent reaches out to a search engine, a calculator, or in this specific case, it calls a weather API with the location data. And that brings us to the observation. The external tool executes the action and returns a concrete, real-world result directly back to the agent. The agent now observes. Temperature is 30 degrees and snowing. This grounds the AI in reality. It's no longer guessing. It has hard facts. But here is where the real magic happens. The loop starts over. That observation feeds right back into a brand new thought. The agent realizes, wow, it's cold, but my warm clothes are in storage. I need to layer up. This continuous cycle allows the agent to handle exceptions and adapt on the fly, just like we would. If an action fails, it simply observes the failure, thinks about a workaround, and tries a different action. You know, the power of this loop really cannot be overstated. By forcing the AI to cycle through thoughts, actions, and observations, it effortlessly decomposes massive goals, tracks its progress, handles unexpected exceptions, and constantly gathers real-time data. But beyond all that, it makes the AI entirely traceable. If the agent makes a mistake, you can look at its internal monologue and see exactly where its logic went off the rails. It turns this opaque, black box AI into something you can easily trace and debug. Section 4. Does it actually think? Now, what's really interesting about this slide is, well, it introduces a dramatic twist to our narrative. There is currently a massive active debate within the academic community about why this framework actually works and whether the AI is doing any real thinking at all. A major critique from a paper under open review states that the perceived reasoning abilities of these models stem entirely from exemplar query similarity rather than any inherent reasoning abilities. In plain English, they're arguing that ReAct agents aren't actually reasoning through problems. They're just incredibly good at mimicking the examples provided in their system prompts. If we neutrally walk through the data from this critical finding, the results are pretty fascinating. The creators of ReAct claim that interleaving thoughts and actions helps reasoning. But critics found that if you change just a few synonyms in the prompt or slightly alter the goal, the AI's performance absolutely plummets. Even crazier, if you replace the AI's logical thought with a totally random placebo sentence, basically gibberish, the AI often performs just as well. This suggests that the agent might not truly understand the task at all. It might just be acting like a student mindlessly copying answers from a textbook because the pattern looks familiar. It's a fascinating debate, and it is far from settled. Section 5. The future of agents. Regardless of whether they're truly reasoning or just performing highly advanced pattern matching, the practical utility of these agents is undeniable. And developers are already looking ahead, building upon the ReAct framework to solve its lingering limitations. If we look at the evolutionary timeline of AI, we started in the past with one-shot prompting, asking a question and just hoping for the best. The present is ReAct, interleaving reasoning and acting to gather external data. But the future? That's something called reflection. Reflection takes the basic ReAct loop and adds a crucial new capability, learning from past failures. See, a standard ReAct agent can sometimes get stuck. If it tries to open a file that doesn't exist, it might just keep trying to open it over and over, trapped in an endless loop. A reflection agent, however, introduces a reflect step. When it receives a failure signal, it pauses to verbally evaluate why it failed. It might say, okay, I see that trying to open this file failed twice, therefore the file must be named something else. I'll search the directory instead. It proactively corrects its own errors and navigates around roadblocks, forming a much more robust memory over time. So the crucial point is this. The days of AI just generating text in a vacuum are ending. AI's biggest blind spots are being solved by closed-loop systems. The ReAct framework, following the continuous loop of thought, action, and observation, allows models to ground their internal logic in real-world, real-time data. And while the academic debate fiercely continues over whether these models are truly reasoning or just executing highly complex pattern matching, the applications are transforming technology as we know it. Which leaves us with a massive question to ponder as we watch this technology evolve. As these agents get better at checking the weather, booking our flights, and correcting their own mistakes, are we building AI that truly thinks, or are we just building AI that follows a highly complex script perfectly? It's something to keep in mind as you see more and more of these agents enter your daily life. Thank you so much for joining me to unpack this fascinating topic. Keep learning, keep questioning, and I will see you in the next explainer.